How to fix exploding gradients in PyTorch deep networks. Imagine training a neural network and suddenly the loss jumps wildly or turns into none. That's what exploding gradients can do, making training unstable and unpredictable. If you've ever faced this, you know how frustrating it can be. But don't worry, there are proven ways to fix it. Today, we'll explore how to keep those gradients in check during your PyTorch model training. First, the most common method is gradient clipping. It's like setting a speed limit for your gradients. During backpropagation, if the gradients get too large, clipping scales them down to safe level. PyTorch makes this easy with functions like torch.nn.utils.clipgradnorm and torch.nn.utils.clipgradvalue. You simply specify a maximum norm or value, and PyTorch takes care of the rest. For example, after calling loss backward, you can add clipgradnorm model parameters. Max norm is equal to 1.0. This keeps the total gradient norm below 1, preventing wild updates. It's simple but very effective. Next, consider batch normalization. This technique normalizes the activations within each mini-batch, which helps keep the scale of the gradients more consistent. When activations are normalized, the gradients tend to stay within a manageable range, reducing the chance of explosion. It's especially useful in deep networks where gradients can become unstable as they pass through many layers. Another approach is weight regularization, also called weight decay. This adds a penalty to large weights in your loss function, encouraging the model to keep weights small. Smaller weights lead to smaller updates during training, which can help prevent gradients from blowing up. L1 and L2 regularization are common choices, and PyTorch makes it easy to add these penalties when setting up your optimizer. Sometimes the network architecture itself can cause issues. Using models designed for stability, like long short-term memory networks for sequence data, can help. These models are built to handle gradient flow better. Also, reducing the depth of your network or switching to activation functions like ReLU variants can make a difference. ReLU functions are less prone to causing gradient explosion compared to sigmoid or tan. Monitoring your gradients during training is also a smart move. You can check the gradient magnitudes of each layer after backpropagation. If you see some layers with extremely large gradients, you know where to focus your efforts. PyTorch allows you to inspect gradients easily by printing model parameters after loss backward. Visual tools like TensorBoard can also help you see how gradients change over time. In practice, combining techniques works best. Using gradient clipping along with batch normalization and weight regularization often results in more stable training. These methods are especially useful when working on complex models like those powering AI tools such as ChatGPT, DALL, or Midjourney. Managing gradients carefully is part of building reliable AI systems that behave predictably. Here's a quick example of how to implement gradient clipping during training in PyTorch. From torch.nn.utils import clipgradnorm. Hash after computing loss and calling backward. Loss backward. Clipgradnorm model. Parameters. Max norm is equal to 1.0. Optimizer step. This simple line ensures that the total gradient norm does not exceed 1. By applying these strategies, you can keep your deep networks training smoothly and avoid the pitfalls of exploding gradients. Remember, controlling gradients is key to building models that learn effectively and produce consistent results.